So the Cartesian plane, let's draw one and plot some of these points. So a Cartesian plane is a coordinate system, and we have two axes. We have a y-axis and an x-axis. X is horizontal, y is vertical. And let's have a read of what we're doing here. We're doing two calculations. We're going to work out the distance between 2 points, and we're going to work out the coordinate of the midpoint. So we have two formulas there. Example problems 1a. Find the distance between the points 2, 5 and minus 3, 7. The first thing I'm going to do is just sketch them, plot those on the Cartesian plane. Okay, so we have a coordinate 2, 5. Now, in the Cartesian plane, this central coordinate, that's 0, 0. We call that the point of origin. And then we have x going across, so we would have 1, 2, 3, 4. And then we have in the negative direction, minus 1, minus 2, minus 3. Okay, we've seen that in sort of year 7, year 8 onwards. And then the same for the y-axis. So going up, we have the positive direction, and going down, we have the negative direction, right? Okay, very good. Now, we have here coordinates, and they're always listed as x, comma, y. We always state the x coordinate first, just because that's how the alphabet goes. X, Y, Z, right? Here's the x coordinate, here's the y coordinate. So if I'm going to plot this point, we've gone across 2 spaces. The x value is 2, and the y value is 5. We've gone up 5 spaces. That's going to be my first coordinate. The second coordinate is x is minus 3, but y is 7. So 1, 2, 3, and then up 7. Here's 5. I need to go a bit higher. 6, 7. So that's where my second coordinate is. Now I'm asked here, find the distance between them. How far is it if you're going to walk from here to here? How many grid units is it to walk that distance? Now we're going to use the distance formula here. So I'll write up the distance formula. Now this looks like a long formula, but it's actually a very simple one. And you've got that stated there. Our first coordinate is x is 2, y is 5. And our second coordinate is x is minus 3, y is 7. Now what I'm going to do, and I'll get you guys, this is where you guys will start filling in with me. Okay, so now that we're going to find the distance, we're going to solve question 1a. We always label the first coordinate x1, y1. Okay, the second coordinate, that's going to be x2, y2. Okay, now all we are going to do is substitute these coordinates into this formula. All right, so I'm going to put x2 where x2 is. All right, so let's do that together. If you've got your pen, let's write that out. The square root of, and we have in brackets, x2. Now, all of x2 is minus 3. Okay, the negative belongs to it, so we're putting minus 3 in the brackets here. We have minus 3 for x2. Take away x1. What's the value of x1? x1 is 2. And then that is squared. Okay, plus we're going to do y2, which is 7, take away y1, which is 5, close the brackets, and squared. All right, so very straightforward. Now let's start to evaluate it a little bit. Minus 3, take away 2. All right, so hopefully we're pretty comfortable with our number lines and so forth. If I'm at minus 3 and I take away 2, I'm going minus 3, minus 4, minus 5. All right, so we're going to have in brackets minus 5. That's what that one simplifies to. And then we have 7 take away 5. That's going to be minus 2. And now we can evaluate each of those. Minus 5 squared. That's minus 5 times minus 5. That's positive 25. All right, and then we have minus 2 times minus 2. That's going to be positive 4. 25 plus 4 is 29. The square root of 29 will be just above 5. It'll be about 5. .38. Okay, now one thing, we'll talk about a number of things up here. One thing you'll see me do consistently is whenever we're doing figures, I'll always write 4 figures, but then round to 3. Okay, that's a rule we have in 11 methods. We round to 3 significant figures. So I've written 4 numbers here, and the 4th number rounds upwards. Okay, any questions about that one? All right, so what we've done there is we've found the distance between this point and this point is 5.38 units, grid units on the Cartesian plane. Very good. Now let's find the coordinates of the midpoint. Okay, so this is part B. Find the midpoint between the coordinates. So the midpoint, that's just the coordinate that's halfway between them. All right, so somewhere in here, there's a coordinate that's in the middle of both of those. That's the midpoint, the point that's in the middle. And this is the formula for the midpoint. Notice how there's a comma here. That's because the midpoint itself is a coordinate. This is going to be the x coordinate, and this is going to be the y coordinate. So again, all we're going to do is substitute x1 and x2 into our formula here. So we can go m for midpoint is x1, which is 2, plus x2, which is minus 3. So we have 2 plus negative 3, and all of that is divided by 2. Then the same for y, we have y1, which is 5, plus y2, which is 7, divided by 2. All right, so when we add these together, 2 plus minus 3, 2 take away 3, that will be minus 1. All right, so I have at the top minus 1, and at the bottom I'll have 2. Over here we have 5 plus 7, that'll be 12, and at the bottom we have 2. And we can just simplify that a little bit, right? Minus half is the same as minus 0.5, and we don't care which way you write it. Either of those is perfectly suitable. 12 divided by 2, you do need to simplify. 12 divided by 2 is 6. Now, let's talk about what that means. The coordinates of the midpoint, the point in the middle, it has an x value of minus 0.5. So if here's 0, here's minus 1, minus 0.5 is there. So that's the x coordinate of the midpoint, and the y value is 6. All right, we can see that from our Cartesian plane. Mine's a little bit skewed because I haven't got a grid that I'm drawing it on. I'm just doing the measurements by hand. Okay, so how's everyone feeling about that? Is that a bit pretty easy? Would we like to do another example, or do you want to try some questions? What do you reckon, Rainey? Another example? Excellent. Okay, so let's go through quick example 2 then. So I'll clear some space or spin the board around. All right, so in example 2, we won't bother sketching it this time. We'll just get straight into it. Find the distance between the coordinates, and we have x is minus 1, y is 3, and we have minus 2 and 4. Minus 1 and 3, minus 2 and minus 4. Make sure you get them down properly. All right, the first thing we'll do, we'll go through and label them. x1, y1, x2, y2. Now, ultimately, it doesn't matter which one corresponds with the subscript 1 and which one corresponds with subscript 2. The only important thing is that this is the x coordinate, this is the y coordinate. Okay, I'm going to write the distance formula again so we can see where we're substituting it. You don't need to do this. All right, I'm just doing this purely for explanation's sake. But here's where we need to start showing our working. x2 goes there. That's our first thing we're substituting. So we have minus 2, take away. x1 is minus 1. And that's going to be squared. Then we have plus, and we have y2, take away y1. That's going to be squared. And then we just start to evaluate it. What we have here is we have minus 2, and we have two negatives. Negative, so it's like minus 2, take away negative 1, that becomes plus. So it's minus 2 plus 1. That's what's going on there. I'll do a number of things I will do over multiple steps just to draw out some of the skills. Minus 4 take away 3, that will be minus 7. That square root extends over both of them. Now, minus 2 plus 1, that's going to be minus 1. And we have minus 1 squared. So this simplifies to minus 1. Minus 1 squared will become positive 1. Minus 7 squared is positive 49. And so our answer is the square root of 50. All right, now we expect that to be just over 7. 7.07071. Okay, so I've got 4 figures there. 1, 2, 3, 4, and the 1 rounds down. So our answer will be 7.07 units. That's the distance between those two coordinates. Okay, so any questions about that process? Just here we had we just calculated that rather than having another step involved in it. We said minus 2 plus 1, that will be minus 1. Okay, let's do the midpoint for those ones then. So the midpoint formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So let's have a look. x1 plus x2. So we have minus 1 for x1. And we have plus minus 2 for x2 divided by 2. So all you're doing, right, is just substituting the number where you see x1 and x2. We've got a comma in there, and we have 3 plus minus 4 divided by 2. All right, we'll start to evaluate these. If I have minus 1 plus minus 2, that's going to be minus 3. And here we have 3 plus minus 4, that's going to be minus 1. Now we can leave our answer like that. We've expressed both as a fraction. Like another way it could be stated if we wanted a decimal, minus 1.5 and minus 0.5. All right, both of these are fully correct. Okay, so looks all right. We went through these other two a bit easier. So let's get you guys to have a go before recess. Now, to start with, if we just have a look at the checklist on the front again. All right, I just want to point out, notice how we have linear equations, basic skills recap. Okay, so to begin with, we're doing a summary from the old Year 10 textbook as sort of a segue into Year 11 methods. We won't pick our textbooks up until next week, and then you can see from the Hazy 11 methods, we'll start chapter 1 and chapter 2. Okay, so normally now we would continue with our textbook work. Because we don't have our textbook work yet, we have a printout of the Year 10 maths book, and that's at the end of your notes booklet here. So if we flick to the end, I'll take you through that. you'll find a section called Linear Equations Booklet. It's probably 5 or 6 pages from the end. I should put page numbers on. Linear Equations Booklet, exercise 11A. Alright, so let's keep that page in mind. Now, looking at the front, alright, it says must complete question 1, recommended optional extension question 5. So that means right now you're going to complete all of question 1, and then if you want you can have a go at question 5. It will get a little bit tricky with question 5, but definitely question 1. So we have enough there to do question 1, 11A, and question 1 from 11B, finding the distance in 11A, and finding the midpoint in 11B. So let's do that before recess. That sounds okay? Yeah, absolutely. Grab a book if you need it. Yep. All right, let's get started on that.